Welcome to another session of the PMDG MD11 training from Angle of Attack. In this episode, we will be discussing the asymmetrical takeoff and a fuel dump. This time around, we're lined up on runway 25 left at Hong Kong with everything set for a medium haul flight. Our weight is similar to that during the normal takeoff tutorial, so we'll see an interesting comparison of climb performance with one engine out. Now, there is no room for error on this one, and I'll give you a head start by saying up front that there will be an engine failure after V1. So for now, let's assume all is normal and advance thrust to approximately 70% N1. Check for stable readings, then push auto flight and advance thrust levers until auto thrust kicks in. Verify thrust set and airspeed alive.
Thrust set.
V1 is our go, no-go decision speed. Failure before V1 permits an abort, but after V1 we are committed to flight and must get airborne as we talked about before. Maintain centerline and keep scanning the PFD and
V1.
engine instrumentation. Engine failure number 1.
Rotate.
Correct immediately with opposite rudder pressure. Rotate smoothly and pitch to maintain
Positive rate.
V2. At positive rate, bring the gear up and use a rudder to keep the slip skid indicator at the top of the attitude display coordinated. Follow the flight director roll commands and maintain pitch for V2. You are ignoring the pitch on the flight director. When you feel confident that you have control over the aircraft, bring up the McDo and press line select key 6 left to confirm that you have indeed lost an engine. This causes the FMS commanded speed to change to V2 and will allow us to use the flight director as a pitch reference. Follow the flight director now and continue using rudder to coordinate the aircraft. At approximately 800 feet above the ground, the flight director will command a pitch down to accelerate. This early start to the acceleration is another consequence of confirming engine out in the FMS. So pitch over and start using rudder trim to reduce the pressure you have put on the pedals.
Flaps up.
Remember to retract flaps on schedule as well. Also, you can engage autoflight to relieve yourself of some workload, and let's call the tower.
Auto flight.
Tower angle 01 heavy has an engine out, will need to return to the field.
Angle 01 heavy, roger, continue along departure, climb 7,000, maintain 240 knots, we need dump fuel, sir.
Continue along departure route, climb 7,000, maintain 240 knots, affirm on the fuel dump, angle 01 heavy.
Angle 01 heavy, roger, report established en route Rumsey for the hold instructions.
Will report en route Rumsey, angle 01 heavy. On the FCP, set 240 in the speed window, 7,000 in the altitude window, and pull both knobs to select the new values. Verify on the flight mode annunciator that the correct autopilot modes are set. Although 240 knots is a shade above slat's retract speed, we will leave the slats extended as we don't want to play too close to the stall margins. As we roll out of this turn, we'll call ATC. Angle 01 heavy is established en route Rumsey.
Angle 01 heavy, roger, fly direct Hazel, hold at Hazel on the 160 radial, right turns 240 knots, maintain 7,000.
Fly direct 2 and hold at Hazel, 160 degree radial, right turns 240 knots at 7,000, angle 01 heavy.
Angle 01, roger, read back correct, let me know when you're finished in the hold.
Wilco angle 01. Bring up the McDo, clear any messages in the scratch pad, and press the direct intersection function key. Enter Hazel and drop it in 1 left. In our case, a duplicate names screen has come up as there are 2 waypoints named Hazel in the database. Select the closest one, then press 1 left to confirm it. Note that the ND immediately updates to reflect the change and that the aircraft starts to turn now to fly direct to Hazel. Now press the line select key next to Hazel to go to the lateral revision page for that waypoint. Press line select key to right for the hold and enter 160 for the inbound course, and right turns are selected and the lake times will remain at 1 minute. Insert this data with line select key 6 left and verify on the ND that the hold is displayed. Things have settled down now, so while we wait for the aircraft to reach the hold, let's do some housekeeping and finalize this engine shutdown. Pull back the affected engine's thrust lever to idle and set the corresponding fuel selector to off. Now let's run through the after takeoff checklist. Gear up and lights off. Spoiler handle disarmed. Auto brakes off. Flaps retracted and dial of flap 15 set for the approach. We will leave the slats where they are as discussed earlier. On the overhead, the main thing that jumps out at us is the set of amber indications on hydraulic system number 1. Low hydraulic pressure is to be expected as this system runs off engine number 1, which is of course no longer running. While we wait for the aircraft to reach the hold, let's have a chat about what has happened so far. So, when an engine fails, both McDo's automatically revert to the performance page with prompts to confirm an engine out. When confirm engine out is selected, the FMS engine out computations and guidance become active. So until you confirm engine out, pitch guidance from the flight director will be for V2 plus 10. The correct procedure for an engine failure prior to attaining V2 is to accelerate and maintain V2. Since we are entering the hold, let's start the fuel dump. Bring up the McDo and note the discontinuity message. A route discontinuity is inevitable at this point as we have set up a hold and not linked it up with the rest of our flight plan. So clear the discontinuity message and press initialization function key, then page to proceed to the weight initialization page. Our current gross weight is shown here on the right. The maximum landing weight of the freighter version of the MD11 is 491,500 pounds. As you can see, we are overweight for a landing, although not by much. Now, with that said, we are still going to perform a fuel dump to our maximum landing weight just for safety reasons. Press page again to get the fuel initialization page. In line 1 right, we will input the gross weight to which we want to dump. Enter 491.5 here. Below the new figure, we see the dump time. It will take approximately 7 minutes to dump enough fuel to get down to the inputted weight. Now on the overhead, open the guard for the dump switch and press it. With the fuel system in auto, all transfer pumps will come on automatically. That is one of the beauties of this MD11. So go to the fuel synoptic on the SD and verify that fuel dump is active. At the top of the display, we are shown the current gross weight and fuel quantity. When the gross weight reaches 491,500 pounds, fuel dump will be stopped automatically by the system. We can see on the EAD that there are alerts waiting for us on the miscellaneous page of the system's display. So anytime there is an alert specific to one of the SD pages, the corresponding switch illuminates white. Press miscellaneous to extinguish the light and get to the miscellaneous page. Autopilot single and single land are enunciated. There are consequences of hydraulic system number 1 being unavailable, and we need not worry about them unless an auto land is required, which shouldn't be given the current weather at Hong Kong. So let's jump forward a few minutes now and resume once we're nearing our max landing weight once we have dumped some more fuel. So looking at the fuel page on the SD, we are rapidly nearing our target gross weight of 491,500 pounds. Fuel dumping will be halted automatically once we reach this weight, as we talked about before. So there we are. Amber alerts show that the fuel dump valves have been closed. Now you can go to the overhead and press the fuel dump switch to disarm the system, and note that the alerts have gone away on the SD. With the fuel dump complete, we're ready to exit the hold and return to the field. Approach angle 01 heavy.
Angle 01 heavy, Hong Kong approach, go ahead.
Angle 01 heavy is underweight now, and we'd like to make our return.
Angle 01, roger, exit the hold at Hazel, turn left heading 070.
Exit at Hazel and left 070, angle 01. Go back to the McDo and press the flight plan function key. Press line select key 1 right to command the FMS to automatically delete the hold once we pass the fix. When we pass overhead the fix, the autopilot will revert to heading mode. So turn the heading knob to 070 and the aircraft will turn onto that heading. So, aviators, as we leave the hold, so too do we leave behind the asymmetrical takeoff and fuel dump. You've got to be pretty unlucky to have an engine fail on you so late in the takeoff roll, but when it happens, you'll be glad you were ready. The go, no-go decision at V1 is one of the most critical you can make as an MD11 pilot. The kinetic energy of the aircraft as it rolls down the runway increases with the square of the speed. This means that if you double the speed of the aircraft, the energy that is required to stop it will quadruple. Quite amazing. To put it simply, busting V1 by even a few knots, then making the decision to abort will dramatically increase the amount of runway that it takes to stop. So there are actually plenty of instances in the real world where airliners have come to grief following a faster than V1 abort, unfortunately. The initial climb out is tough. Initially, you will need to ignore the flight director pitch bar as it is providing guidance for V2 plus 10. Follow the roll commands though, and use rudder to keep the slip skid indicator in check. Once you select confirm engine out in the FMS, the flight director will provide pitch guidance for V2. And I say all that just as a reminder and a refresher. Now, the manual flying part of this procedure is the toughest element. The fuel dump is for the most part procedural, but it does bring into light important considerations about the weight of the aircraft for landing. The MD11 is a long-haul aircraft, so the majority of the situations where a return to the airport of origin is required, the aircraft will be overweight for a landing. Landing above max landing weight is possible, and if done well, will not damage the aircraft, but should only be done in the most critical of emergencies when you have to get down. Any aircraft landing overweight will require inspection for damage, so you'd better have a good reason and you better have good answers. I'd say that just about wraps it up for this one. Until next time, throttle on.